Hi, everyone. Welcome to this recording demo today. Here with me there is Clemens, and uh, let's start.
That was unceremonial.
I had like a double microphone. I don't know how.
Right. Good evening, everybody. My name's Clemens, and I'm a platform architect at Humanitec. And in this capacity, I'll be your technical tour guide today. So, we are having our recurring demo of Humanitec's platform orchestrator. And yeah, we'll do just that. And I heard today I'm doing more than usual with AI. Let's see what happens. Hmm. So I'm a confessing desktop messy. Give me a few seconds to sort everything out so I can actually show you my desktop. Oh, there's already something in the chat. Hello, I'm interested in having a demo of Humanitec. I would like to get someone to reach out to me. Hello. Hey, Kieran. Antonello, who is acting incognito as Christoph today, is already reaching out to you. So awesome. You guys solve that in the chat, and I'll just trundle off into our usual demo. Yeah. Everybody else who's listening to this, if you would like to have a more custom demo, tailored to your tech stack, tailored to your situation, your specific problems, yeah, please reach out, and we'll be happy to set something up. Apart from that, I stop doing sales right now and go off into the demo, right? All right. I'm always doing that wrong. So today it's going to be different. I'm going to mute uh, my notifications first, and then I share my desktop. It's unprecedented. All right. So for housekeeping, um, I will not be looking a lot at my chat, but if I look at anything, I'll be looking at the chat, right? And possibly also at the Q&A tool at the end. But if you have any questions in between, just post them into the chat and I will try to pick them up as I go along, right? And then we see. Right. Humanitec's platform orchestrator discovery call. Yeah, as I said, I won't be doing any sales, but that's like the first slide of something that you would see inside of a sales presentation. But I'm going to steal 2 slides from here to give you a little bit of framing. So, what is a platform orchestrator to begin with? A platform orchestrator is an API-first rules engine. It helps humans, tools, and AI to provision, manage, and secure infrastructure consistently. That's what a platform orchestrator does. So hopefully that means something to you, because if it does, then you're in the right demo. And to give you a rough overview of how the architecture of that thing looks like before we drop off into the specifics, let's take a look at this slide here. So first of all, the platform orchestrator sits over here. Yeah, that is separated from the runtime infrastructure over here, and for a specific reason. The runtime infrastructure is always yours. The platform orchestrator could be yours, could also be ours. We offer the platform orchestrator as a SaaS tool, but also as a self-hosted instance. So that might be all one, or it might be here SaaS cared for by Humanitec, and here runtime infrastructure, where only the outcomes are orchestrated into. Well, who's interacting with the platform orchestrator? Mainly two personas, platform engineers who are actually configuring the orchestrator to carry out its tasks. Yeah, we'll look into all of those nifty little objects of the platform orchestrator's object system in a few seconds. And then we have developers who are using the platform orchestrator to actually deploy releases into the runtime infrastructure. And yeah, we'll see how that works and who's actually doing what here. All right, so now that you have a general idea of how that is panning out, let's jump right off into the specifics and get you acquainted with how a usual workflow might look like. So I have prepared a little bit of infrastructure. All of that is running on top of Azure. And usually that's the point in time where I point out how quickly all of this works. But as you can see, this did take 3 hours and 22 minutes. That is everything but quick. So what happened here? I can tell you what happened. I actually started to provision this infrastructure right before I went out of the door with my 2 kids and brought them to their swimming lessons. So they were learning to swim better. I was trying to do a little bit of sports, and then we returned. 2 hours later, they had to be fed, and now they are hopefully in bed. And so 3 hours and 15 minutes later, I came back to my machine in good faith that the infrastructure would be up and running. But lo and behold, it stopped right at the point where the plan was finished, asking me if I actually wanted to deploy. Now, so the actual provisioning time was 7 minutes, because then I said yes, a little bit panicking because I knew you guys would be waiting for me. Yeah, so 7 minutes later, I had my infrastructure, so now we can play around with it. So RVOV tutorial. All right, let's go over to the UI of the orchestrator and take a look at that. RVOV tutorial. Okay, so that is a project. A project is a binder for environments, and environments actually get deployments. I do have an Azure Dev and an Azure Score environment here, and they are sitting around here, and nothing has been deployed to this environment yet. All right, that's not a lot. So let's change that, right, and see how the platform orchestrator actually projects something. And we're going to do this a little bit more platform engineer style. So I do not have prepared a full platform. Yeah, to be late is better than to get used to auto approve and forget it later. Nah, sometimes. It all worked out in this instance. So yes, I do agree. Yes, I kind of do agree. So RVLV tutorial, that's what we're deploying to. And as I said, we're going to do this a little bit more platform engineer style. So no full platform is in effect here. I do not have end-to-end pipelines where I can shoot deployments around. I will do this by hand. And then I will later ask my good friend Codex or my also good friend Claude. I don't know, probably we do it together. We will deploy a little bit more and then see how AI actually interacts with the platform orchestrator as well. All right, so, but first I'm going to do this manually. We do have a CLI called HCDL or HCuddle, and we want to deploy something. And we want to deploy it into this project. And as we have seen, we do have an environment that's named Azure Dev into this environment. And I do have a feeling that in here I do have a manifests folder, and inside I have a few manifests. And a deployment manifest actually describes what I want to deploy. So let's start with a really, really boring manifest.yaml. Why is it really boring? You see in a second. But first of all, we want to deploy that. So what the orchestrator is telling me, hey, checking project and environment, they do exist. That's good, because if they wouldn't, we couldn't be deploying anything. For last deployment, we're checking as well. No previous stateful deployment, generating a diff. No changes detected. This will be a redeployment. So empty redeployment. Sounds spiffy. Okay, but let's do this. Okay. So now we're waiting for the deployment to complete, which should be kind of quick. And here we go. It's completed. And the reason for that is, hidden inside of the manifest.yaml. As you can see, that says workloads and then an empty object. So we've essentially deployed nothing, but at least we know that the orchestrator is actually able to connect to our infrastructure, our runtime environment. It is able to talk to the other side and drop off a deployment request. And that is actually being handled and is reported back as completed. So actually we've done a full round trip. A full round trip through what? Let's find out. So if we actually want to deploy anything, the first thing that we need is a so-called runner. Because on top of a runner, all of the magic is happening, right? All of the modules that we want to deploy are being executed. Why do I say modules? Well, because Terraform is the daily driver for the platform orchestrator. So Terraform or OpenTofu, that is. And the reason for that is that almost any of our customers were super happy when we had our first shot for an orchestrator to have the flexibility of the driver meta model to be able to deploy through any means, so any IAC language. Everybody was happy for that during sales conversations. And then later we did take the numbers. So we measured, and it was over 98% of all requests against the platform orchestrator V1, which were actually just executing good old Terraform. So we doubled down on the decision that our customers made by voting with their feet. And we made Terraform the daily driver for the platform orchestrator V2. And this is what you're looking at. V2, the brand new model, which is able to not only deploy to Kubernetes, but to any kind of runtime fabric, and which has Terraform now as the daily driver, or HCL code. Could also be handled by OpenTofu, as I said. And of course, you can let Terraform start anything that you want it to start, which could be a different ISC language. Yeah, you will see me use, for example, Ansible later during this little demonstration to do a little bit more than just talk to Kubernetes clusters. Kubernetes clusters are still very handy, at least during demos, because they are just fast. Containers start fast, I can deploy things fast, I can show you more on top of Kubernetes and less if I do other things. So that's the reason why I'm still mainly demoing on Kubernetes. All right, so nothing has been deployed to this environment. Let's reload that and see that we actually did deploy something. No resource dependency graph available. Well, because we essentially deployed nothing, but at least we had a successful deployment, as I said. So that happened on top of the runner. So the runner is, in this case, a pod sitting in my AKS cluster in Azure, and it's a so-called agent runner. So it sits there and calls back to the orchestrator on a schedule and asks if there's anything to do. And if the orchestrator says, hey, I have work for you to do, it pulls in the job and executes it completely in autonomy inside of Azure. And that means we are able to prepare all of the deployment schematics with the orchestrator and then let everything be executed in isolation, in safe isolation, which means from the runner, you can, for example, connect to your secret stores and be sure that no information will ever be exfiltrated from your networks because all is happening in isolation there. Right, so that's what the runner is. Whoops, sorry. To be able to execute Terraform, the next thing that we need is a provider. And that's the reason why we have providers, because you want to be able to configure them dynamically. For example, the Azure provider wants to be configured for the subscription that you want to deploy to. Yeah, and if you want to deploy to different subscriptions, you need to be able to configure this dynamically. That's the reason why we have providers here. And we allow you, let me take a look if I can show you. We have the Azure RM provider here. Looking at this, you can see I have hard pinned the subscription, but I'm saying, hey, we're using AKS workload identity, which means the actual principle which allows me to deploy to the subscription or not is being injected by the cloud. And now I could use the same mechanism to actually inject the subscription or the tenant based on my current context. And then I would actually configure this provider dynamically. Bad example. I think I do not have a fully dynamically configured provider here because during this example, I simply don't need to have one. All right, anyway, we were over here looking at our non-existing deployment. Okay, that's what providers are. Essentially Terraform providers. Terraform providers run Terraform modules. But in our case, we also have something in between that is called a resource type. A resource type is basically a contract between the platform and the platform engineer on one side and the platform and the developer on the other side. The platform engineer knows, according to the resource type, I need to deliver this information back to the platform. And then the platform knows what to proxy on, so to speak, to the developer, and the developer knows what he gets to be able to make his application interact with the infrastructure. For a database, for example, that would be something like a database name, a user, a password, a port, a host. Yeah, all of those 5 informations are needed to build out a classic connection string for a database that is relying on all of those parameters, like Postgres, for example. Yeah, so if you have that, then you can connect to the database. That's the reason why the resource type covers all of that information. And finally, we do have modules, and they are of a resource type, as you could have guessed. Executed by providers on top of a runner. And they are actually provisioning all of that stuff into a project, into an environment inside of a project. And the environment can also be of a type. Why that is important, we will see in a few. Okay, but now you know how all of the entities basically click together in the object model of the orchestrator. And now we can take a look at actually generating something. Yeah, because that deployment manifest here is super boring. Let's take a look at manifest 2 YAML. So this is a lot more. Let's see what's in the package, and then we just deploy the thing. All right, we do have a score workload here, which means we are basically deploying a container. Yeah, so that's the container image, and we do actually want to talk to this Postgres database here. And as you can see, I'm asking with this placeholder syntax here from the resources, the one called db, give me the outputs, the username. If I scroll a little bit down, I can see here is a resource called db of type Postgres. You could guess it, all of the 5 parameters I mentioned are in here inside of that connection string. Yeah. But they are not hard-coded. They're simply being asked for by this placeholder. That's the reason if I deploy this and let the orchestrator provision the DB, it will be able to put it into this variable and make it accessible by that as a runtime, as an env to this container which is being deployed. All right, let's do this. And the good thing is all I need to do is add this 2 here to the command line and execute that. Now we are diffing against nothing, and this time we are actually adding demo app. That sounds like a plan. Let's do this. All right. So now let's hop over here and take a look at our project. At our Azure Dev environment, deployment is running, but we can already take a look at the resource graph. So in here, we do have a route for routing our score workload with the Postgres database, and all of that is connected to a namespace. Well, I do have asked for route to be provisioned here. Funny enough, this is pointing at funny code where we do not have any kind of domain name reserved, but let's find out if we can access it anyway a little bit later. All right, so that's what's happening here. And now we actually want to find out if that is also happening on the cluster. And then we want to motivate our AI friend to probably help to do a little bit more. Okay, but first of all, what I want to do is I want to AZAKS Let's see. No, I do not have this. AZ, AKS, get credentials. My best guess is RVOV. First deployment, AKS, and then we have the group RVOV first deployment RG. Let's see. Close, close. Yeah, that's what happens when you mess up single and double minus. Resource group. Ah, okay. RVOV for yeah. Okay. AZ groups list. Did you mean group? Okay, I did. So RVOV first deployment RG is okay. Okay. Before I go mad, I do TF state list grep AKS. Let's see. And why not go over here? No, that's fine. Sure. RVOV first deployment AKS. Okay. So that's the point in time where I hated that we are inside of a webinar. Nobody's shouting at me and even did write it into the chat. I'm very sorry that I didn't notice. You have fist instead of first. And that's right. I totally messed up. Sorry for that. Okay, cool. So now we do have that. Let's make sure that we are actually on top of that context and do a kubectl get namespaces. So, okay, cool. So we have a suspicious namespace here, which is 4 minutes old. So let's do a kubectl get all on the E19 namespace and see what we have here. We have our database pod and our demo app running happily. We have the database access services, but we also have our demo app services, which is exposed only on the cluster IP. Yep. Okay, cool. So let's do something because it's so much more fun if we do let AI work instead of doing this ourselves, right? So, and because I want to be I have a super interesting life. I'm going to start Codex here with dangerously bypass approvals in Sandbox, which means I can now actually have some fun. Yeah, because I do let Codex work on all of the files which are in here. Do only do this inside of an environment where you are sure that your AI agent cannot go wild on you. Yeah. I am running this inside of a sandbox, so I'm actually making sure that I do have a very secure isolation and border intact here. Even if I'm telling it that it can exit its own sandbox, it's not living anywhere else than in another sandbox. Okay, so once again, do not do this if you're not inside of a sandbox. But apart from that, Actually, get yourself a good sandbox and then do it. And the reason why I'm saying this is because I've been on this AI journey for a little bit longer. And this is one of the crucial findings of my own AI journey. When I started, I was basically trading work for work. Yeah. I was actually trading away programming things for writing good queries. Yeah. For writing prompts. And because prompts were not that consistent, I was trading away of writing code for writing specification documents. But essentially, it didn't take less time. I was just doing something different. And the only way to escape from that is to let the AI thing do its thing. And to be able to do that, you need to let it actually work and work away from you. So the only way to let it work unattended is to actually use this string here, at least for codecs, dangerously bypass approvals in sandbox. So now it can actually do all kinds of things without you telling it all of the time, yes, that's fine for me, please progress. Yeah, so that's the only way to actually trade away herding cats or AI agents, which would interrupt you all the time from a different task. Yeah, for the ability to write a prompt, let the thing do its thing, and then in the end, actually get back to working in yeah, peace. Okay, so having said that, the first thing that I want to know is, hey buddy, I have deployed something with Humanitec v2 into an AKS cluster. There is a route active, but it has the wrong domain name, and I don't know under which IP I can reach the cluster ingress. Can you get me the ingress and then create a code command that will ask the ingress? Or the app called demo app, but with the wrong domain name injected so I can see something. Aha. Okay, it's found the first deployment AKS. Okay. And this is now literally the interesting part, right? Because I can now lay back into my chair and wait for the AI to actually do the resource, do the research, yeah, and see if I can get something. So, cool. So that here should actually connect me with the funny code DE, which is my route, yeah, into the cluster. Okay, cool. Let's start a new terminal and see if that actually works out. And sure enough, this not only gives me a 200 okay, it actually gives me a database result 0. So I know that my app is connected to the database, and it gives me a metric crap ton of information about my environment that normally shouldn't be exposed because there might be secrets inside of envars, but this application is simply dumping them all out. So let's quickly scroll over them. Yeah, and you can see, so get was going to funny code DE, and that's the reason why we got some output. Now, what we could actually do is we could add this IP to our ATC hosts and add it under the domain funnycode.de. And then we could actually, inside of our browser, reach the demo app. But that goes a little bit far. I don't want that. Yeah, because I know this is kind of stupid. I rather would like that to actually work. So let's see what we can do. Do you think we could make this work for a real domain? Could we change the ingress configuration to work with a nip.io domain? So nip.io is a service that allows me to call to a domain using its IP. So I can just take any IP. So what was this one? That was 52, 155, 174, 53. So I could ask for that .nip.io, and that would actually get me to this IP address. Okay, so let's see. Let's actually get that into a browser. And there we go. That's our demo app. So much to platform engineering with AI, right? The only part is that feels wrong, right? I do have an AI agent actually interacting with my Kubernetes cluster here. And now that thing is changing the configuration of the resources in the live. This is why platform engineering is not the right term for this. This is rather vibe coding my infrastructure. This is what makes this whole AI thing for infrastructure so intimidating, right? There's that agent and it's doing some stuff with my infrastructure. If it gets anything wrong, I mean, I'm giving it pretty basic things here, but if it gets anything wrong, then that means rather my application is offline or there's a ton of security flaws to be introduced, right? This is exactly what we don't want to have. And that is the reason why we actually want to go to a little bit of a different route, right? We want to use the orchestrator in the background to make it very safe for an AI to procure infrastructure, but through a very defined interface. And we're going to use the same interface as we are giving developers, right? Because that is an abstraction. This here is an abstraction. Yeah, I can ask for the thing to deploy a container. I can connect it to a database, but only one that is under my control, right? Because I'm asking for the same database here. And that means now the orchestrator has in its hand how a database actually looks like. There's no coding agent trying to figure out, okay, how can I make this work? Yeah. In the same way that I'm asking here for a route, yeah, and I'm getting an outcome that was in place already. It had the wrong host name because I was not asking for the right one. Why wasn't I asking for the right one? Why? Well, I didn't know, right? But let's make this more consistent, right? Let's get to the same outcome, yeah, and do it in the right way. Okay, that was fun, but dangerous. Don't do that, please. We want to stay on golden paths. And because of that, I only want you to procure infrastructure or change it through alteration of a deployment manifest. Please tell me if you understood, and we'll honor this for the rest of this session. Understood. So far, so good. So let's go from here. Okay. We want to get the same outcome, but this time with the orchestrator. Yeah, okay. More info, but to the same. All right. Please do patch my manifest2.yaml by inserting the nip.io domain. And I'm deliberately giving it a lot more context here than I would if I would be working here on my own, right? I'm doing this as a show for you guys. So I'm giving it a lot more context, and I'm literally formulating out my thoughts here. So it is more transparent for you what I'm thinking. My reasoning is, in this case, more transparent to you than what the AI is doing, hopefully. Okay, so inserting the nip.io domain instead of the bogus funny KDE, and then redeploy this using hcuddle CLI. Please deploy to our RVOV tutorial project and Azure Dev environment. If you don't know how to do that already, please inspect hcuddle CLI help. Yes, of course. GitHub Copilot or Claude Code works totally similarly. They all have their specifics. Codex is basically like a basement dwelling IT nerd who's quite robust. So Codex isn't hurt or gets anxious if you shout at it, yeah, or do stuff like that. Ah, look, now we actually have the modified file here, right? That was injected as asked for. And as you can see, I'll run hcuddle deploy rvov tutorial Azure Dev. Yeah, so that's actually deploying in the background. And let's take a look over here. As you can see, this is deploying. Yeah, that has already gone through the successful deployment cycle. And that means now reloading this is actually not going to break. Yeah. But this time we have made the change in a very secure way, because now there was nothing that the AI agent could do wrong, right? And now I can ask it for different things like, hey, nice. Now I want to deploy the same workload twice. Can you double my demo app workload as demo clone, but connect it to the same DB? Please move the DB into shared resources for that. If you don't know how to do that, please take a look at manifest 3 as an example. Then I want to have another route, which is also working for the clone. Please deploy as well when finished. Let's see. Right. So as I said, Codex is totally okay if you shouted it in all caps. It will not be anxious or back off from something if you threaten it, if you are outright hostile. I do not advise you to do that because I think if AI takes over the world at any point in time, I want to be on its buddy list and not on the other side of the equation. Yeah, so I treat AIs as coworkers. Do not do the same with Claude, for example. If you shout at Claude, Claude actually reacts by being super cautious all out of a sudden. Yeah, it will ask for confirmation a lot more and things like that. Yeah, so let's see. So interesting thing to note. In the background, you did see the background color change probably. And the reason for that is with every deployment, the background color is actually chosen randomly. So with the redeploy, now we are getting a different background color. All right. What we also possibly get is my demo clone route. Okay, let's open this up. Yes, I do totally trust this. Let's see. And we have a different background color on that one because it's randomly chosen. Yeah, so now we have actually two deployments by just telling the thing to do that. Let's not take this for granted, but let's take a look at our manifest too. What did change in here? Actually, we moved Postgres into shared resources. Great. Now we have workloads. We have our demo app. And if we look a little bit lower, we should find our demo clone. That one has also the demo clone route, and all of that is deployed as it should, as it looks. But as I said, don't take things for granted. I'm not allowed to cheat here. So what I'm going to do is I'm going to cube, if it lets me, kubectl, get kubectl get all on the namespace I think it was E19, right? Yeah, E19. So looking in here, we do have one DB only, two applications, one app, one clone. We have the two services. And if I would take a look at the routes, I would see that they would be pointing at the right pods as well. Okay, so much to platform engineering with AIs. Now, I will not show you the part that you shouldn't be doing, right? And this is me currently rather driving from the front end. Yeah, what you shouldn't be doing is driving from the back end. So let's take a look at the insights of the orchestrator quickly before we open it up for Q&A. Yeah. Yeah, that also contains what you shouldn't be doing. Because if I take a look at the modules here, for example, right, you can see I do have, let's say, my my HTTP route. Yeah. If I take a look at that, I can see, for example, it has a dependency specified on a namespace. That's the reason why I never needed to ask for a namespace. As soon as I have a route, the orchestrator knows, okay, there's a dependency on a namespace, and it will put one on the graph if there isn't one already. Yeah. It can take a few parameters like the host name, path, service, and service port. So that is what is actually exposed to me as a developer over here. I can give those params in. All of the rest is not modifiable. Yeah, for example, the inputs here that my gateway namespace is Envoy gateway system is not modifiable by the developer. Yeah. And then behind that backing is a Terraform module, which is living under revision control here. Yeah, so if I open up this repo here, You can see that this is a Kubernetes route. We do offer those as open source modules, a few of them, which do make sense. And if you take a look at the Terraform code, you can see that there's not too much, but a little bit to this route module. What you shouldn't be doing is now telling your best friend like Codex or Claude or whomever, hey, I would like to deploy a Redis cache. Can you quickly pull a Redis module for Terraform out of your virtual behind and vomit that into my orchestrator configuration so I can deploy a Redis cache right away? Why shouldn't you be doing that? Well, the answer is simple. That would be exactly the same as me messing around with the route in the beginning, just with a little bit of indirection. So this is how the disciplines actually converge. You have the platform engineers in the background who actually give you the golden paths, this stuff here, which is exactly how it should be. And then you can have the AI and the front who can now very consistently and safely request all of that infrastructure, because that is always going to be instantiated in the right way, also by a robot, but this time by a deterministic one, which is called the platform orchestrator. All right, so much to platform engineering with a little bit more AI than usual and what a platform orchestrator does. I have not had time and chance to show you a ton of other things. I would usually love to show you, like how I provision virtual machines, for example, how I use Ansible to configure virtual machines from Terraform and all of that stuff. But as I said in the beginning, if that was interesting enough for you to take a deeper look at our system and want to understand all of that, well, then you can either go ahead and register yourself a demo subscription. You can get one for 30 days for free, a trial one. And then you can go to our documentation, which is under developer.humanitec.com. And you can go to the tutorials, first deployment. And in here, you will find in tutorial form, you can probably run this in an hour, all of the stuff that you need to get your first deployment going on top of the cloud provider of your choice. And also, deploy some VMs, use Ansible to configure them, all of that stuff. That's all in the box. And if you would still like to understand even more, well, then just give Antonello, Christoph, and Incognito a poke, and he will be happy to set up a meeting where we can actually make all of the other stuff happen. Well, so much for that. And now I hope that you have a ton of questions for me. Or for Codex. Yeah, I can relay any kind of interesting prompt to Codex. I cannot see the Q&A tool, Antonello. Is anything in there?
Yeah, there was a question about the change of color during the demo app. If it was done by the AI did it by itself, or if uh, yeah.
Hey, this one went from, I think, something like baby blue to bright lilac.
Yeah.
I don't know. I'm not good with colors, but what I can safely say is that I can set a background color here if I want to, as it says. Here I can set override color. But if I don't, then it will change upon deployment to a random background color. So let's see, override color equals. Why not? I mean, we can do that quickly. So we have variable here. Let's do override color as well. Well, obviously blue doesn't work. We need to inject the hex color. So FF, what is a nice color? EE04. I have no idea what kind of color this is. Um, yeah, thank you. That looks better. And now we have our demo clone as well. No, that was the demo clone. Let's go up here and do this one as well. And do, I don't know, EEFF instead. That's going to be horrible, I guess. Please redeploy. I changed to some horrible colors.
In the meanwhile, Clemens is actually a very nice question. So Pratek is asking if the orchestrator only work with Kubernetes or also can orchestrate ACS on Fargate.
Oh, that is a great question. And it also lets me off the hook easily because I can simply answer yes. Ah, there you go. There you go. That is definitely a color change from, I don't know, pinkish thing to wholly yellow. And also the other side is slightly more pleasing yellow. That is like, holy moly, attention yellow. And that is more like, I'm delivering your postage yellow, at least in Germany. All right, so that was not the best color choice here. Okay. I am horrible with colors. Can you change the hex code for the app to something soothing green and the clone to something alarming red and redeploy? So, um, so the real answer is yes. Humanitec V2 can deploy to any kind of runtime environment. That could be a serverless solution. That could be VMs. That could be Kubernetes. That could be something different altogether. Yeah. Um, we have deployment models with some cloud providers, which even have abstracted virtual machines away and now are calling things denos or stuff like that. Yeah, we can basically deploy anything that has an API. Okay, that is an alarming red. Now I hope we also have the soothing green as asked for. Ah, much better. Alarming red is not good on my eyes. If you do enough with infrastructure, you know what I mean. That color really triggers us, right? All right, cool. But that's how you can do it, right? You can give it a color by providing an override color. If you don't give it a color, it will choose one at random during deployment. And that's the reason if I deploy it enough times, then you will see also colors cycle. Right. And if that is interesting to you, um, yeah, that's the GitHub repo. Astro Mesa demo app. Great little demo app from my old colleague Ben. I'm loving it. Yeah, he also has like the yellow on the example. Nice. Okay. If you don't have any other questions or interesting prompts that I should relay to my friend Codex, I would say let's close it down for today. Give you a little bit of time to digest and hopefully come back for the next serving.
Fantastic. Thank you so much, everyone for joining and for the great question. Also, this demo is available on YouTube. So if you want to share to your colleagues or to anyone, just on the Humanitec YouTube channel, you can find it. So with that being said, thanks everyone, just on time. And thanks, Clemens, for this amazing AI demo.
Thank you, everybody. Have a wonderful evening, day, or whatever it is